This is a demonstration of the RESNET automated tests using the TECTITE 4.0 software from the Energy Conservatory. And when you're doing automated tests, you'll need to make a connection between your DG700 gauge and your computer. And I'm showing you three options here for that cabling. And if you've got a gauge that's newer than November 2009, your gauge will have a USB communications port, and it will come with a 15-foot cable that has the mini USB on one end and the standard USB on the other. The other two options use the serial communications port, the 9-pin port, and we're showing a USB to DB9 connector, a 9-pin connector, and then a communications port. Those come in lengths of maybe 6 or 10, could be 25 or 50-foot communications cable, and you use that along to make the connection with the gauge. Another option is we do also have the DB9 to Cat5 adapters, and that allows you to use long lengths of Cat5 cable. We've used up to 3,000 feet of cable and not had a problem with communication. So it gives you the option, the nice option of being able to have a longer length cable and set up your computer at a table, maybe a kitchen table, dining room table, to do the test. And then that uses the same USB to 9-pin cable as in the second diagram, so these cables are the same. So once you've downloaded the TECTITE 4.0 software and launched it, this is the screen that will come up, and then we'll go up to the upper left here to File, the pull-down menu File, and we'll click on that. And your options are either a new test or a new test with a custom configuration. And we recommend that you set up a configuration file to begin with that includes your logo, your company logo and name. So you'll choose new test with custom configuration. You'll enter your logo and company information in there, and then you'll save it as a configuration file. And then the next time you're starting that up, you'll go to new test with custom configuration, pull up that configuration file, and all that data will be there ready for you to use. So I've already set up a configuration file, so we will open that up. There we go. It'll have a CFA configuration file extension, and we'll open that one up. And as you can see, I entered all of the data that you can enter in these tests, but we're not going to take time to go through all those data entries. We're going to focus on the three automated tests. So the default method, once you get to the test settings page, the default method will be auto. And the standard test standards, we have three options: the CGSB, which has always been in TECTITE, and then the three new options in TECTITE 4.0, the one-point, multi-point, repeated single-point tests. And we're going to start out with the one-point test. Now when you click to this page, it's going to start searching for that communication. And now once the status goes green and says idle monitoring, it's showing that you made that connection, and we can click Start Test. You see on the right here it says Start Test. We'll click on that button. Now it'll prompt us to enter our temperature data and our elevation. We don't need to enter the temperature unless we have a 30-degree temperature difference, but as long as we have the software, we might as well, and it'll make those adjustments for temperature. And the temperatures need to be within 10 degrees, so they're trying to make it pretty easy for you. And the altitude, if you're above 5,000 feet, you're required to enter it in, but and it needs to be within 2,000 feet. So we would recommend just entering in the temperatures and the altitude to do the test. Now it's prompting you to cover the fan inlet to do a baseline reading. And with this test, it's going to do, with the 1-point test, it's going to do 5 10-second baseline averages. And the status bar will tell you which baseline it's on. The seconds here will tell you how many seconds have gone by, and samples, it's showing what, it's doing multiple samples per second. And then the baseline reading is going to be displayed here, what it's finding. So it's taking baseline number 4. Once the baseline numbers are all entered in, it'll display what those 4 readings were, what the average was, and what the range was. And the range is going to determine the accuracy. The difference between the highest and lowest baseline is going to determine the accuracy. And if it's between 0 and 5, which it is, we're within 5. We're pretty close to the same temp inside and outside, and not much wind today. So we went from about positive 0.1 to negative 0.4, which is a range of 5. It went from 4 to 0 and then 0 up to 0.1, and so you've got a baseline range of 0.5. And that's well within the standard level of accuracy. As long as that baseline range is 5 or less, it's considered standard level of accuracy. If it's between 5 and 10, it's a reduced level. And you could choose to repeat those baseline readings with a longer averaging period. You might enter a 30-second average in next time and see if you can, and that range will tend to flatten out with those longer readings. And then when it takes a blower door reading, it'll do a 30-second average on the blower door reading too. If you end up outside of the standard level of accuracy, you may decide to go to either a multi-point test, a RESNET multi-point, or the RESNET repeated single-point test. So we're going to continue with the test. It's asking us to put on the appropriate flow ring. We've got flow ring A on. My assistant is pretty quick here. So we'll proceed with the test. And now the status line says we're adjusting the fan for 50 pascals, and I'm going to help it along here a little bit and speed it up. And it's going to show what our building pressure is over here and what our flow is. And then once it gets close to 50, it will start automatically taking data points. Or once we're satisfied that we're pretty close to 50, we can hit the sample button, and then it will take samples. It'll start taking samples. And that's it. Single point test is done. We'll look at the next page, and we're at about 1990. And we've got a standard level of accuracy. So we'll save that test. So we'll go up to File, Save Current Test File. So pull down menu under File, Save Current Test File, and we'll call that test number 1. Alright, so once we're done saving that, we can clear our data. And it'll always give you this warning when you push that clear button. We already saved it, we know we saved it, so we'll choose yes. And then I went previous, and we're going to change to a multi-point test. So I'm just toggling back and forth between previous and next, between the test settings screen and the test graph screen. So now we can start our multi-point test. It's going to ask us for the temperature and altitude again. And cover it to take our baseline reading. And with this test, it's going to take a pre-test baseline reading and a post-test baseline reading. So, and these are all 10-second averages. And then all of the data points will be 10-second averages also. Now it's asking us to put the appropriate flow ring on, and we've got flow ring A, so we'll have that all set, because as soon as we click that, it's going to start adjusting the fan, and it's adjusting it for 60. So the RESNET test standard is looking at it'll take 8 data points between 60 and 15, and it'll equally space those data points between 60 and 15. And it'll take 10-second averages at each of those data points. So now we're shooting for 54, and it'll take another data point right around 54. And our next target is 48. So as you can see, when it's a calm day, it'll go through these data points pretty quickly. And I'm pushing the sample button once it gets pretty close, and that's speeding it up a little bit. You may find you'll get a little bit more accurate test if you wait for it to adjust on its own a little bit. I'm helping it along just to speed up the test a little bit. It's looking for 30. It searched for 30 pretty quickly there. And building pressure, we're pretty close to 30 on that one. Now it's searching for 24. So it calculates after it's done taking these data points. It's going to calculate the let's see, we're searching for 18 here. Once it's done taking the 8 data points, then it's gonna calculate the coefficient and the exponent. Now it's asking us to cap the inlet of the fan to take the last baseline reading. There's a lot of required analysis with the RESNET standard. Calculate the coefficient and exponent, the correlation coefficient, and the accuracy. And it looks like all of our points are fitting really well on a line there. We need to have a correlation coefficient. That's how well those points fit on the line of 0.99 or higher, and we're 0.999, so we're about as good as you can get on a test. Showing a coefficient and exponent and our CFM flow. So now we can save that test. And we'll call that our multipoint. Okay, now that we've saved that, we can clear that data. And we're going to go to previous screen, and we'll choose our repeated single point test. And we'll go to next. Okay. Toggling back and forth there, start test. And we can do between 5 and 20 tests. We're going to do the minimum because it's pretty calm today. We'll choose 5. We'll enter our temperature information and our elevation, so it can correct our CFM for based on that information. Now it's measuring our baseline pressure. So it'll take a 10-second baseline test. So it'll do a baseline. Now it's asking us to cover, put the appropriate flow ring on. We've got ring A again. It's adjusting our, and this is at 50 again. So it's gonna do 5 tests, a baseline and a blower door test for the first test, then a baseline and a blower door for the second. And each of these are 10-second averages. So now it's ready for the second point. It's asking to cover up that inlet again, and it'll take another baseline reading. So it's taking our second baseline reading. And it is possible to take these readings manually and enter them into the software. Appropriate flow ring. Proceed. Adjusting for 50. I'll speed it up a little bit. Move the test along here. It is possible to take these numbers manually and enter them into the software, but then there's some statistical information you need to figure out to calculate the accuracy and the precision of the test. Cover fan inlet. My assistant's doing a great job here today. Measuring the baseline pressure. Appropriate flow ring. So we just kind of keep repeating that same thing over and over again. Adjust the fan speed up. So the statistical analysis to calculate all of those things, the accuracy of the test, you can do manually, and it gives you instructions on how to do that in the test standard. But it's certainly much easier to just use software. It's really not going to save you any time to do it manually. But if you don't have a computer in the field, you may have limited options. Okay, we're going to take one. We're ready for appropriate flow ring, ring A, and we're ready to take our adjusted fan speed for our fourth test. And you can see all those data points are almost on top of each other. So we've got the luxury of a calm day today, and it's pretty easy to get good test data on a calm day. Our last baseline. We're covering up for that, so we're taking 10-second baselines and 10-second blower door readings. Appropriate flow ring. Proceed with test. Adjusting fan speed. There we go. So we've got pretty good precision. Standard level of accuracy, we're at 0.7 for our accuracy. So we can go to saving this test file. And we did a repeated. Okay, and then we'll take a look at a report, give you an idea what the report looks like. Lots of test data here because we filled in all the information. Our CFM at 50, air changes per hour will be calculated if you enter the volume in there if you're doing building code testing. And go to our next page and it has all of your data in there. So all the data you entered in there is in there, which is a nice feature to have all your data points, your temperature, relative humidity, and if there's any deviation from the standard, it will show up there. So that's using RESNET or using TECTITE for the 3 different types of automated RESNET testing.